All right, welcome back. Let's talk about why substitution works. At the heart of why this is going on is, remember, by the fundamental theorems, differentiation and integration kind of undo each other. And so that means every rule about derivatives will correspond to a rule about integrals and vice versa. And the relevant rule here is the chain rule. So the chain rule is a differentiation rule, but it'll correspond to an integration rule, and it'll turn out to be, it's what we've been doing with substitution. So let's start off with some capital function whose antiderivative is little f. You can write it that way, or you could write it this way, the integral of little f is capital F plus c. Okay. Now, if we take capital F and plug in a function on the inside, then if we want to do the derivative, it's a chain rule problem. Okay, so the chain rule says it's the derivative of the outside, evaluated at the inside, times the derivative of the inside. But remember, capital F prime is little f, so that's little f, g of x, g prime of x. All right, that's the derivative rule. The way you make it into an integral rule is just to integrate. So you get the integral of d by dx, f of g of x, dx, is the integral of f of g of x times g prime of x, dx. But this is the integral of a derivative. So that'll just be the original function. Okay? Because f of g of x is, of course, an antiderivative for its derivative. Let me rewrite this on the other side. And this actually formally is the official statement of the substitution rule. It says if you want to integrate f of g of x times g prime of x, the answer is capital F of g of x plus c, where capital F was the antiderivative of little f. Okay? That's actually what substitution is. It looks different than the way we wrote it, but to see why it's the same thing, we would have phrased the problem this way. We would have started with this side, and we would have said, oh, we should use that substitution method on it. And so we would have said, let u be g of x, because that looks like the inside part. And look, its derivative is staring us in the face, so that'll definitely work. And so then we would have said du dx is g prime of x. We would have solved du is g prime of x dx. That would have made us happy because we see that here. So then we could have used our substitution method and written this as f of u, because g of x was u, times du, because g prime dx was du. And then we would have said, oh, well, we know how to integrate f of u, because capital F is the antiderivative, so the answer is just f of u plus c. And then finally, we would have plugged in the u. We would have said, oh, well, u is just g of x. And so you see, our method gives the exact same statement that the substitution method is. It's just this differential approach is an easier way to remember it and work with it, so that's how most people do it. But anyway, that's why substitution works. All right. See ya.